So hopefully you guys were staying up with your assignments over the last couple of weeks. If there are some you didn't do, if you click on the grade book, you can see the assignments there, and you should be able to open them up with late passes. The longer you wait, though, the more late passes it'll cost, so don't wait too long. Got some handouts. Oh, yeah.
What do you call? What do you say? We like. We haven't.
What's that?
No, I'm talking to Tyler. Yeah, he's kind of good.
Yeah, I'm done.
Who are we missing? Page. And somebody else?
No one, I think.
Oh, yeah. Okay. All right, I just was typing this up.
Yes, you did.
So we have 3 assignments due Friday.
Yeah, but it's for this week.
I mean, it's already Wednesday. We only have 5.
They're not long.
Oh, okay. Oh, no.
I don't think they'll be too hard.
They're only like 9, 11 points.
All right, I got this up on the screen, but you can look on your paper. I just want to go through some of this vocab. Hopefully you know some of it already, but just want to be clear. I just typed this morning. Already in the first sentence, I have a typo. I have plural equations, which I shouldn't, but whoops. All right, so if you look at the first graphic that you have on your, you guys would pay attention.
Oh, yeah. We're just talking about Sophia's boots and tee that she's had to get this home.
A what?
Her tiger.
Oh, a T.
Her tiger foot.
She was telling us she did like a 2 ounce to 8 ounce ratio of Tito's, and then we were like, Sophia.
Calm down, guys. So if you look at the first graphic up at the upper right of the side with graphics on it, Elias, Sophia, take off the sweatshirt, by the way.
Yeah.
Tell Eli to take out his earphones.
I can still hear. That's funny. He said, we're doing what's on the board. I'm going to do it on the board, but it's in front of you. And then he was like, Eli, and he was like, Sophia, and then he was like, Sophia, take your sweatshirt off. And I was sitting here listening.
All right. Well, try not to talk while I'm going over this so that other people can hear. I'm sure they'll be more interested in what you're saying than I, but. So your first graphic, you've got a parabola. And we're going to be getting into now solving quadratic equations this week. We'll have a few different ways of doing it, and I'll even show you some online calculators that can help you do it. But I just want to go over the basics. So if you remember, the point of symmetry on a parabola, we called the vertex. That rings a bell, I hope. The 2 points where they cross the horizontal axis, those are the zeros of the function. We call them zeros because the y coordinate there is 0. If you input an x at certain values, the output is the vertical coordinate. So that's 0 for certain inputs. It's the inputs that we call the solutions to the equation. So when you solve a quadratic equation, you're finding those solutions where it crosses the horizontal axis. And you're really just pointing out the x value of those because we know the y value is 0. Is that okay? Now, there's a couple other names for the zeros. They're sometimes called roots. Now, the roots of the equation. And you could call them solutions. So just know that those three terms all describe the places of intersection. Some quadratic equations, when you solve them, if you look at that second graphic, I don't know if that makes sense to you, but I kind of like grade out a parabola and grade out another one. And as it goes up, you can imagine me like lifting it up. And the points that are the solutions get closer until you get one that just touches the line and doesn't actually go through to the negative side. It just touches and bounces back. And in that case, the two solutions have the same x value. So that has a special name. Again, there's multiple ways of describing that. A lot of times we'll just call that a double root because the two answers are the same. Sometimes, some people you'll hear talk about a multiplicity of two. So they'll say the answer is maybe x equals -3 multiplicity 2, because both answers are both -3. And you might even hear that people call it degeneracy of 2. So when two things become the same, we say that they're degenerate solutions.
I was looking at pages 8.
Okay, that's fine. You can sit wherever.
He said after this week we're done with math the rest of the semester.
So I was talking just now about the second graphic on the sheet. And there are some cases where the two zeros are the same number, and that's where the thing does not actually cross through the axis. There are cases, like the last graphic, where the parabola never crosses or even touches the horizontal axis. In that case, there are no real valued solutions. There's no number on that number line where it crosses, where the function's 0. Now there is another set of numbers which you'll be learning a bit about later. We call them the imaginary numbers. They're not really imaginary per se. They were given that name because when they were first discovered, people gave them that name as a sort of criticism, and it kind of just stuck. But they're called imaginary numbers, and when you have a number that has a real and an imaginary part, we call it a complex. We'll get into that more in the future, so don't worry too much about that right now. But when you have a parabola that does not intersect the x-axis, the solutions, you will still have two solutions, but they'll be complex numbers. They won't be real numbers on the real number line. So there's no place on the number line where it crosses. But you can still solve them. So those are just some definitions, just to help you guys kind of understand. The next page, I just described what factoring is kind of all about, because we're going to be doing that for a bit. What we basically have is we're trying to solve a quadratic equation. So you'll see I put one as an example, x squared minus 5 equals 4x. Maybe I want to find when x squared minus 5 becomes equal to 4x. Where do those two sides of the equation intersect? And if I pull that up on Desmos, you can see what that looks like. So there's x squared minus 5. And then here's 4x. And finding the solutions would be finding where these two things intersect. That's kind of what we're doing when we're solving these. What we do, though, when we solve these is what we usually do is move everything to one side of the equation. So when I say, what's x squared minus 5 minus 4x? Then I'm finding when is the left-hand side, the original left-hand side, different than the right-hand side, or when is that difference 0? So if I hide the originals, I get a new function, and now finding these points are the same as what I was doing before, finding where these things cross. But we usually move them to the same side of the equation and find when this is equal to 0. And we do that by what we call factoring. So on that sheet, I have that example. Can you guys see that okay? Well, you got your sheets. Then I just move everything to the left-hand side. We usually arrange it so that the powers of x are descending. And this has 3 terms that are subtracted. What I'd like to do is re-express this as a product of 2 things. Because if I can find when something times something equals 0, I know the answer will be whenever one of them is 0, because anything times 0 makes 0. So the answer will either be when a is 0 or b if I write it like this. So here's the example of that function. We set it equal to 0, and we factor it into 2 factors that are multiplied. And this product will be 0 when either one of these is 0. So those are how we get the solutions. Now, the way I factored that, if you look at that example, was I found a number, 2 numbers that multiply to -5, but add to -4. So -5 and 1 would multiply to -5, but if I added them would make -4. So that's what I choose for my factors. And then I just set each factor equal to 0 for the solution. Have you guys done that before? Is that familiar to you at all? Or did you guys do any of that in Algebra 1? Okay. So that's factoring, and we'll spend more time on that. We'll see how that goes for you guys, and we can adjust things. Another way to sort of automatically accomplish factoring is to use the quadratic formula. I put the quadratic formula here for your reference so you can use it for your problems. In that case, you just identify a as the number on x squared. So you plug in a. B is -4 here, so that's the second number. So you plug that in wherever you see B. And then -5 here would be C. You just plug it in at this point, and those give you your 2 answers. You just use that formula. You do have to get the equation kind of in this form where it's all on one side equal to 0 before you can use this, but that's, you could just plug things in and get your answers that way. So you could factor it by trying to figure out how to factor it, or you can just plug into the formula and just crank the wheel and let the answers fall out. All right, so that's just what I wanted to go over. You have some assignments. So these are basic quadratic equations. I'll do a couple so that you see. Let me put this over here, actually. And we'll walk through a couple steps, and this will be the first assignment. Hopefully you don't find it too difficult. All right, you guys would pay attention. This is a quadratic equation. It's not too tough. It's maybe the easiest class of them. Well, I'll just do this one real quick on the side. What would the solution to that equation be on the right?
X equals 3.
That's one of them. Because this says something times itself equals 9. It could also be negative 3, right? So don't forget that. When we square root both sides, you'll get x is equal to plus or minus 3. You can write it that way. That just means it could be plus 3. A second option, it could be minus 3. Is that okay? All right. To do this one, we want to get this bit here all by itself. So we want to get that alone on one side of the equation. What should I do to start that process? Pay attention, please, so that I don't have to repeat this.
Just put the squared on them, so like 5x squared minus 5 squared.
No, first I want to isolate that part. I want to get it by itself. So right now it's getting multiplied by 4, and then 6 is added to it.
So we're gonna take away the 4 and then 6. Like move it to
I'll
the-
start, yeah, you could do that. Usually you start with the 6. So I'm going to subtract the 6. And then what does that give me? Uh, 36, yeah, good. All right, now I can divide by 4 on every term. And now it looks kind of like this one over here. It's, something squared equals 9. So at this step, all you got to do is square root both sides to get rid of the square. And that'll get rid of the square here. So you just have 5x minus 5. And that becomes your plus or minus 3. So it's two separate equations, really. It's 5x minus 5 equals 3. And 5x minus 5 equals negative 3. Solving both of those will give you a solution. But you can write it all at once with the plus or minus sign. And then just solve for x. So I'm going to add 5. So I got 5x equals, I'll put the 5 first since it's positive, plus or minus 3. And then I will divide by 5 finally. So my x could be 5 plus 3 divided by 5, which would be 8 over 3. Or it could be 5 minus 3 over 5, or 2 over 3. Those are my two solutions. Are you guys okay with that? Does that make sense?
So when we put them like in here, do we have to put like both, or do we just put one?
You'll put them, and I think they usually want commas separating them.
Alright.
So just put a comma, and it should work. So that's mostly how the first assignment goes. It's just a few problems of practicing that. Let me see what the other thing was. And this one just assumes you're going to use the formula where you plug it in. And this one has some practice with factoring. So why don't you guys start on the basic equations for a while?
So they're all pretty much the same thing.
Yeah. And you just have 9 of them, I think.
No, I just meant like all 3 assignments are basically the same.
Well, this one is kind of like what we just did.
Yeah.
The quadratic formula, I can go over how to use that when you get to it. You really just identify what's your A, B, and C, plug it into the formula, and then it's just calculate what those numbers are. And then the factoring one involves sort of thinking about how to factor them. So it's involves a little bit more thought, but it's what I covered on that sheet of paper. Does that make sense?